Twitter sent out, get the bot in here, and get the Discord posted. So, we should be good. Hello, everyone. This is Chris Ingerson, and it is time for me to walk on screen. But also, August 11th, and this is the August 11th TextQuest Devstream. So, to get started, we are basically doing what we were supposed to do yesterday, except I embarrassed myself when I was coding. And I would like to state for the record, I was on the right track. I was correct in stating that I had to basically normalize values based on screen width and height. However, I was incorrect in what values I was trying to normalize. I was trying to do mouse position. It should have been the canvas's resolution, because the canvas's resolution can be independent of the actual the screen width and height. So I needed to properly normalize those values to get the correct adjustment value for deltas. I'm going to take a drink real quick. Okay. Now, to show you where we are currently, I'm going to... Oh, shoot. That'll be fine. So, I have draggables working in a much more coherent way now. They actually are pretty nice. I have inertia supported, so I can actually click and drag and fling it up, and it'll automatically stop when I do that. This, in the background, you can see that it's constantly staying at the right position on my pointer, assuming that it doesn't do something like this where I just keep going and it can't follow me. It's not perfectly in sync. It is, so it's always in the correct spot, but it's not perfectly in sync necessarily, and that is because of a couple of things. Basically, the way dragging works, it's not always like forcing to position of the mouse. Instead, it's just eventually going to get there. So usually you'll see that it's like a little bit behind where my mouse is, but if I stop moving, it always comes back to the same spot. I guess I'll click in the center here to make it a little bit easier. So like it always comes back to the center where I clicked. The only time it won't is if I basically drag it too far to the right, at which point it clamps and it won't scroll any farther, or if I do the same going too far up or too far down, same effect would happen. So we now have clamping to within the parent's bounds, or rather clamping to the parent's bounds functioning, and that's largely useful for this draggable map area. Also, a side note, I was thinking that something that would be pretty nice to do is have a map, like a secondary smaller map up here when you're dragging, that basically shows, I guess I could put it in the center here, that basically just fades in and out real quick to show you where all the nodes are in total. So you'd see like a black box with the individual nodes highlighted and then a rectangle representing the visual area of this. That would be a nice way for you to very quickly get over to chunks of code that you know you need to get to. But that's not something that we're necessarily going to do today. That was just something that I was thinking of a little bit yesterday and somewhat today. And of course we have, I don't have it working. I don't have it clamping to be within the bounds yet, so I just kind of flunked that off. I probably shouldn't have these use inertia. The individual nodes should probably just stop. They should only drag when you're dragging, versus the map, which is fine to, I feel, fling around. Because that is pretty funny, but that makes things very confusing, especially because if you like move it slightly and then let it go, it'll kind of drift out of sync. So it'll just be easier for me to do that without inertia on those. So I'm gonna go ahead and turn that off here. So I'm gonna say don't use inertia, and we need to do a custom editor for this, which I think I might actually have. Let me go ahead and come up here. I haven't done any of the editor stuff yet. So let's go to find all references. Really? Well, go figure. All right. I'm going to go to logic node here, find all references, and then this one totally should. It does not. Really? That seems so unlikely. There's no custom inspector for this stuff? Huh. But then how the freak is this going on? I don't know how CG Logic Node is drawing itself if it's a... Oh, it's not a button. That's why. Okay, never mind. Never mind. Right, it's draggable. Okay, I was confused for a second there. I'm like, how is it doing that if it's... So it just isn't using a custom inspector. Okay, so we'll probably draw a custom inspector for this, just because I don't want to show deceleration rate if we're not using inertia. Okay, so the first thing that we need to do here is we need to code our behavior for when clamping is set to clamp to parent, I think, or clamp within parent. I'm going to say useful when dragging smaller rects inside larger rects. Useful when dragging larger rects inside smaller rects. Just kind of putting some quick commenting on here. So confined to parent is what we need to work on. Confined to parent bounds is what the background is currently doing, but we want to set the nodes to be confined to parent, not confined to their bounds though. So we need to come down to here. You can see that in on drag, I have a quick switch statement here that's looking at clamping. If we have clamping set to none, then we don't have to do any of this. It'll just kind of do what it needs to do. But if we have it set to confined to parent or confined to parent bounds, then we have to do some quick adjustments basically. So for this, I'm going to go down to confined to parent bounds, which is here. And we're essentially going to do the same thing now that I think about it. It's just going to examine different values basically, or the same values but in different orders. So I'm going to go ahead and put this, I guess we kind of want to put it here. So it's going to be confined to parent. Is going to be our delta, and we're going to say anchored position dot x plus delta x is less than parent size divided by 2. Actually, can I simplify this? I don't think I ever actually use parent size when it's not divided by 2. So, sure, can we do that? And draggable size is the same, I think. Yeah, okay. So I'm actually going to avoid all of these calculations right here. We're just going to divide everything by 2 from the get-go. Divided by 2f. Okay, and draggable size I think is just a standard reference, so that's good. I think it's the same in this one. Oh, it definitely is, because that's what I just copied it. So we're going to go ahead and get rid of this. No reason to really have that division if I'm going to always divide. Okay, so we're going to say divided by 2f. Oh, and we're obviously going to be coding today. Ooh, freaking really? Hold on. I hate it when you do that. I really should update that to be a little bit more friendly. For some reason, when I click on the top bar for my avatar, it occasionally like stays, and if you keep it like that, like if you double, oh dear, that's gonna just break everything. All right, I'm just gonna leave it as is so I don't accidentally do it. But basically, sometimes when I click on the window to select it, it gets into this weird state where there it is again, where I move my mouse and that resizes the window for some reason. So I got to try to reposition my avatar to be the correct size. I think right about there. And I got to click again. It's weird. I don't know what does it. I don't know why it does it, especially because it's nothing. Anyway, so we're going to say confined to parent bounds, leave that as is. We're going to come up here to confined to parent. This is going to be pretty much the same thing, except instead of basically checking the left side to the left side, we're going to be checking the right side. Oh, no. Instead of checking the left side to the right side and the right side to the left side, top side to the bottom, and so on and so on, we're going to be doing right side to right side, left side to left side, top side to top side, and bottom side to bottom side. So we're going to say if rect transform.anchored position.x, so if the anchored position of our x plus delta dot x, which is the delta is the distance we're moving, is less than parent size dot x minus draggable size dot x, or lerp from draggable size dot x to 0f based on the pivot, which makes sense, I believe. I think all we need to do here, excuse me, is do plus and minus here. So we don't need to worry about this, although I can probably compress this now that I'm looking at it. Something like that. Okay, so we're going to say if our anchored position dot x plus delta x is less than parent size dot x, actually, and we want to say is greater than, so we want to flip these around as well. Okay. So we're saying if it's greater than the parent dot x, so this is the width of the parent plus the, yes, plus the width of the thing that I'm dragging around. Okay, so that's correct. So let's go ahead and organize this a little bit more. Go ahead and do this. And then you can see that I have a couple of things regarding inertia and all that to basically cancel out the velocity if you happen to get clamped, basically, because there's no real point in keeping it otherwise. Okay, so I think we're good there, which means that I can come up to here and say delta is equal to confined to parent delta. All right, and then we're going to go ahead and come up to here. Paste this, we're going to say confined to parent, which actually should go above the other one. So we're going to go ahead and get this right here. I'm going to paste this right here. All right, so confined to parent, get rect size. We're going to divide that by 2f. And then we can get rid of u for this entire thing. I guess I should probably make sure that yeah, okay. So we're going to get rid of all of this fun stuff. I gotta love code cleanup. All right, so that's pretty good. Same thing here, might as well. Divided by 2f, because otherwise we're just going to constantly be calculating those things, and it makes no sense to do that all the time. Get rid of you, and you, and get rid of you, and you. All right, so that's pretty straightforward. Confined to parent bounds. Okay, so for confined to parent, we basically want to do the same thing. If it is, hold on. Here we are. If rect transform dot anchored position dot x is less than size dot x minus all that fun stuff. No. Well, before we do that at all, I'm going to go ahead and set up our logic list here. It's going to have clamping for confined to parent. It's not going to use inertia, so we don't have to worry about that. Okay, let that compile. Okay, so let's go ahead, play, see what happens. Okay. Any moment now. Should it ever choose to. Jeez, come on. There we go. Okay, so dragging seems to be fine still. Let's go ahead and add get bool. So that does not seem to. Ooh, was it? Okay, yeah. No, that does not seem to actually do anything. Although, all right. So confined to parent does not seem to give me anything useful here. Confined to parent delta. So I've done that in the opposite direction. All right. So I believe by default these have a pivot of 0, yep, 0.5, 0.5. We look at the pivot basically because the pivot determines where the drag point is. So we have this mathf.lerp from the maximum width, assuming that the pivot is on the left, which would be 0, and the minimum width, which would be 0, if the pivot is all the way on the right, because we were examining it to the right. So I think we want to say, so parent size dot x, find you parent, transform dot anchor position dot x plus, excuse me, yawning, plus delta dot x, so that's the distance in the x that we're moving. If that is greater than the width of the parent plus, and this assumes, I think, a parent pivot of 0.5, 0.5. I probably could change that to be a little bit more accurate, but it's fine for now. Or a little bit more flexible. Parent size dot x plus, so halfway through there, plus, if it's all the way to the 0, it's all the way to the 1. And we don't want it to be able to move anywhere. Hold on. Do I have this backwards? I think I might want to go from 0 to draggable size instead. So it's basically going to be like this. 0f to that, and then vice versa. 0f, which of course means the opposite here. Let's paste that in. Okay. And we'll be able to tell that actually because the next time we play, I'm going to select the node. And we'll be able to see an outline of it up here. And if it's getting clamped, even if we can't see it, if it's outside the masking area, it should still be getting clamped to roughly outside of it. So we'll be able to see that in action. Also, hello Dusted, welcome back. How are you doing today? All right, so let this compile. Tired? Yeah, I get that, definitely. All right, so that's compiled. Let's go ahead and play. How am I doing? Well, like all times that I stream, we'll see how this stream goes. But it's already going way better than the last one, so it's going to be fun, I think. All right, so I'm going to go ahead and say in-game, get bool. Okay, so it can still drag past that, which is not good. But let's go ahead and grab grid background, nodes, logic node. Okay, so you can, this is what I was talking about, by the way. You can see that the rect is basically the right side of the rect is right outside of it, so I need to reverse that. So was I correct then before? Same thing, yeah. Okay. Do I need to switch that back? That seems weird. Confined to parent bounds. Okay. So we have. So basically, I have to shove it over to the right. So this is position plus delta x is greater than parent size dot x plus from 0 to draggable size dot x. That's the width of the thing we're dragging around. Direct transform pivot is 0.5, which means that it really shouldn't. This needs to be this, so I didn't want to reverse these signs. Okay, let's save that and let that compile. But yeah, I was definitely not enjoying recoding something that I had already coded to work perfectly before. Um, so I pulled, or I referenced some of the old code that I was talking about, um, and made some adjustments to it. And we're actually adding on to the functionality of it, which is nice. So, okay, let's see if that fixed our issue. Yeah, it's mostly just annoying because as I was saying, as I was ranting about it at the time, like these are issues that Unity really should have solved out of the box for you. I feel like having a convenient way of doing that. Um, boop. Yeah, nice. So now this should be confined. So I shouldn't be able to go past the top or the left. There we go. All right. So now let's go ahead and try and do it the other way too to make sure. Okay. So I can't drag it past the bottom right either. All right. Nice. So we now have these nodes confined to the parent, which means that they no longer can be dragged outside of the parent area, or rather the parent bounding box. That's good. I could probably add some sort of padding on that, but honestly, I don't really care about it that much. So, excuse me. Well, while we're at it, let's go ahead and set up confined parent here. So there are two. So I have two different functions that are named the same but do different things. There's confined to parent, and then confined to parent that takes a vector 2. Likewise, there's a confined to parent bounds and a confined to parent bounds that takes a delta 2, or a vector 2. The difference is that confined to parent with the vector basically takes the delta, so that's the delta returned from the pointer data, and it will adjust the delta to get you values that will not break um, your delta movement. So it'll basically clamp the delta values to their allowable values to prevent the draggable from going outside the bounds or going anywhere that you don't want it to. Whereas the variations on those functions that don't take arguments are basically like hard coded, or not hard coded, are basically like safety functions that you can call publicly. They're not protected like the other ones are. So these can be called from anywhere, and they will immediately force the draggable to evaluate its bounds and say, "Oh, I'm outside of the parent area. I should go back," and it'll clamp it to where it needs to be, basically. Okay, so we want to do the same thing here. I do want to reverse these, so I need to take this. We're going to put it up at the front here. Put that up here, here. Do, 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 do. Oops, cancel that. Okay. Mm-hmm. Okay, I'm also going to rename this to parent size and draggable size. So it's a little bit more obvious what is doing what. Okay. Parent size dot x minus. Yep, that should be correct. Crap. I might have actually. Oh, crap! Of course, I did it on the wrong freaking one, so this is going to be renamed bounds. And this is going to be renamed parent. And we're just going to move this up, I guess. Put this back down here. Okay, so confined to parent, we essentially want, yeah, I think that's correct. It's greater than parent size dot x minus, yes, that is correct. Transform, if it's all the way to 0, then we want it to, I feel like I actually have these backwards, but we'll see, I guess. So I'm going to come back down to here. I'm going to say vector is equal to confined to parent bounds vector. And I actually don't remember where this is being called anywhere. Okay, that's just a safety function then, so we might not even have to worry about it for a little bit. So we'll just let that go. I don't think my plan is going to work. Are you talking about the generating templates for code? Is it just compiling incorrectly? Yeah. What issues are you running into? Okay, let's go ahead and clear this. As a matter of test, I guess we can just do it live. All right. So we're going to go ahead and we should be able to fling the map area around. You see that does seem to be working. All right. Let's go ahead and I'm going to grab this. I'm going to turn on use inertia. That was weird. Okay. I'm going to turn on use inertia. So now you can. Oh, what's happening here? Wow, what is going on here? Let's go to confined to parent. What's happening? What is happening? Oh man. Okay, something terrible is going on. Get bool. I can't drag it anymore. Um. Oh right, that would make sense. Okay, let's try that. Really? Okay. Something else must be going on here. Let's see. Previous position. Clamping. Velocity. And is dragging. Velocity is equal to num. If clamping is dragging. Velocity. Hmm. And velocity to x. Interesting. So it seems to be canceling out my velocity, which is a bit odd. Because obviously I can use velocity for my background. I can generate the code. That's not a problem. The problem is Unity doesn't update the assemblies if there is an error in one. So when I do reflection to get field names and stuff, it's using an old one. The only thing I can think of is using the C# file watcher. But I need a. So is there a reason that you don't want to just? So my assumption is that you want the end goal that you want is basically to. So yeah, we have inertia going on there. Let's try this again. Still nothing, huh? How curious. So my yawning. My assumption is that you wanted to basically, whenever you edited those interface classes, you wanted it to automatically update the template code that that you generated, correct? Okay, so while that's going on, let's go ahead and stop playing. I'm gonna clean this up a little bit. No need to do this. Yeah. Is there a reason that you can't just use the events that I posted to basically listen for when that assembly starts recompiling, and then when that happens, delete all of the files in the target folder that you build your code to, and then when it recompiles again, check to see if there. Basically, you'll check to see if there are files below that directory. If there are not, then you're going to create the files, and if there are, you're going to delete them. That should basically force it to. Um, oh, that might actually get you in an infinite loop. So you might have to do some extra safety measures there. But essentially, the idea would be that you wipe everything and then you rebuild it after you've wiped it, and that should handle it, I would think. Is there a reason that that particularly wouldn't work? Here, down to here. So we know that confined to parent bound seems to work here for this, but for some reason, confined to parent itself is causing a problem with our deltas. Parent size. Confined to parent. And I mean, this seems to actually give us the correct values, but now our velocity for inertia is kind of borked. I mean, at the end of the day, velocity isn't a huge loss. I can figure out a different way to handle that. I'm assuming it's just a weird calculation that's happening there. Still, though, it is kind of odd. It could. I'll have to add some kind of caching so it only rebuilds if the specific interfaces change. Yeah, that's entirely up to you how you want to handle that. If you want to do got an attribute on them, I can use like your interfaces have an attribute, or your classes that you generate template code with have an attribute on them. Because you could build basically a centralized database of that stuff on start or on editor startup. So you could basically say like these are all the template classes that are affected by these interfaces, and so whenever one of these interfaces gets changed or this assembly gets changed, the yawning, then you basically just want it to stop, or you want it to delete those files and then rebuild them. Okay. And still, we don't have any sort of inertia support. For reasons, which is very odd. Well, let's see here. Confined to parent bounds, confined to parent, confined to parent delta, velocity, 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 velocity. Where are you being used? This is about what I was expecting. How odd. Well, again, it's a rather minor point. So I'll figure something out. I've got one more idea. Ooh, what are you thinking? So let's see. We now have dragging around feeling pretty good. Um, Everything is now accurately mapping to it. Uh, let's see. Okay. I think I am going to go ahead and work on that map that I was talking about. Mostly because the other things that I need to work on are a little weird and I need to design them a little bit more. So we're going to say logic panel. Let's open this up. Actually, let's go ahead and go to logic map. Go ahead and say C sharp, CG underscore logic minimap, I guess. We'll open that up. And let me see if I can find an example screenshot of this. So there, in Super Smash Bros. Ultimate, there is actually a pretty decent example of this, if I can find it. I think Super Smash Bros. 4 Wii U also did this, where basically when someone gets launched off screen, you get this little map at the top corner of the screen that shows where everyone is and how close they are to kill planes and such. It's basically a good way to let you know where people are. And we would use that as a way of just previewing where chunks of code are. I think Visual Studio 2019 has that as a feature as well. I don't have it installed, so I can't show you. But basically, when you're scrolling, you see like a large representation of your script file, so you can see kind of where specific code chunks are, and you can roughly go to them. So yeah, that's what we're trying to build now. I don't unfortunately have a good picture of that, but it'll fill out pretty quickly because it's a fairly basic concept that we're doing actually. It's basically going to be a bunch of teeny tiny um, like dots, and then a semi-transparent square that shows where the camera is looking currently. So we're going to go ahead and say class that shows where all nodes and on a logic map are, as well as the currently viewed area. Okay, this is going to be a rect mono behavior, I guess. This is going to be in text request. We're going to be using sleepy.common. Got the hiccups. But yeah, that's basically, I would like to, when you're dragging the map around, I would like it to show you a little hover area basically that shows you where in the totality of the map you are, so that it's easy for you to kind of zip around and see any stray nodes that you might have, or just be able to go to specific chunks of logic. So if you have a very complicated map, you might be able to do something with it. So we're going to go ahead and say for our logic minimap, we don't actually need a lot, but I am going to need a few more scripts, I think. Well, yeah, all right. Well, I guess. Trying to figure out if it's cheaper to just update this stuff in the background all the time, or if it would be better to only show it when you start dragging the map around. I guess that would kind of make sense. So then we'll just clear it out. Yeah, okay. All right. So we're going to need a couple of things here. We're going to be using Unity Engine .ui. The logic minimap, I'm going to say, is going to well, maybe it wouldn't require. We'll serialize tooltip. Say private canvas group is equal to null. We're going to say serialize field tooltip private rect transform window rect, I guess, is equal to null. This is going to be rect form representing the visual area. Well, actually, the area of the map currently visible to the player. We're also going to be using system.collections.generic. I don't think we need system.collections. I'm pretty sure we don't anyway. So let's go ahead and we're going to do a couple of other things. We're going to need a header. And this is going to be actually above these things. This is going to be, I can't type today, minimap, and this is going to be header references. Say serialized field, tooltip, blah, 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 private, rec transform. What do I want this to be? Window reference is equal to null. And then we're going to need serialized field, tooltip, private, rec transform, map, background reference is equal to null. I'll just call that map reference actually. And I think that's all we're going to need. Oh, we'll also obviously need serialized field, tooltip, private, what is it, CG, logic. Oh, right. Custom adventures, of course. So there's going to be logic map instead of logic minimap. And we're going to say map is equal to null, I guess. Logic map. There we go. I can't check for changes because the editor script reloads when the code recompiled, so I'll need a data file. Well, so yeah, you can't do anything statically, but you should be able to get notifications when your specific assembly recompiles. Although I guess that doesn't tell you if it's changed, it just means that it's being recompiled. Oh, wait. So I think in that set of event listeners that I sent, I think, let me find it real quick. So you can see there that I have the assembly compilation started and assembly compilation finished events getting fired. On assembly compilation finished, I think that actually tells you arguments, so you might be able to get out error arguments from that. And basically, if you get error arguments back, that would mean that the code was changed most likely and you need to delete it and recompile. But that might not be good because in theory, if you ever have any compilation errors in your code, it would create an infinite loop. So that may not work. But actually, no. Wait. That might be fine because you only want to look at a specific assembly, right? So if you use assembly definitions on the interfaces, you group them all under one specific assembly definition file, you can check to see the name of the assembly. Because if you look at the assembly compilation started and assembly compilation finished, it tells you the name of the assembly versus the regular compilation started and finished. Those are just like all compilations have started and then all compilations have finished. So you would basically only need to look at your specific assembly that you're editing, and then you can determine if it has an error. That means that probably it needs to delete the code and rebuild it, and then it should work for you, I would assume. So I think that will do what you needed. Anyway, back to the logic map. So for this, we are going to want to do a couple of things. I am going to actually have to use system.collections. So using system.collections, we're going to go ahead and say minimap. I'm going to add a header down here. I'm going to call this fading. And we're going to say serialized field, tooltip, blah, blah, blah. Private float duration is equal to, I will say 1f, or actually 0.5f. And then we're also going to have serialized field, tooltip, blah, blah, blah. Private float delay is equal to 1f. So this is delay after dragging starts well, delay after dragging starts. Okay, hold on. Delay to before showing the mini map after dragging starts. And it's going to be let's go ahead and just call this fade delay, I guess. Fade delay, fade duration. How long it takes to fade the mini map in/out. Okay. And then we're going to go ahead and say private IEnumerator fade minimap. We're going to need to do a couple of things. One, I'm going to need a private float fade lerp. Lerp is equal to 0f. No. By all means, like I love talking about these things. And this thing that we're working on, the mini map, shouldn't be too complicated. So I think we still have plenty of time to finish it before the end of the stream today. Okay, so for the fade mini map, all we're basically going to do is we're going to have a start, so float start alpha, float end alpha. No, actually we're not going to do that at all. We will add a curve though. So we're going to say serialized field, tooltip, private animation curve, not calling type, curve, fade curve is equal to animation curve. Stop it. Curve dot ease in out 0f 0f 1f 1f. Pretty straightforward. We're just going to call this curve to evaluate fading alpha along. Okay. So all we need to do here is pass bool fade in. Okay. So we're going to say float t is equal to no. Actually, we don't even need to do that. So we're going to say if fade in, we're going to do something else. We're going to do something else. And all we're going to do here is say while float lerp, not float lerp, fade lerp is less than 1f. We're going to say we'll say fade lerp plus equals time dot delta time divided by fade duration, yield return null. And then we're going to go ahead and say group dot alpha is equal to fade curve dot evaluate fade lerp. Okay. And then at the very end here, we're just going to say fade lerp is equal to 1f. Pretty straightforward there. And then we're going to go ahead and duplicate this. Move this down here. We're going to say while it's greater than 0f. I'm going to say this minus equals that. It is equal to that again. We're going to say this is equal to 0f. It's going to be equal as well there. We should be good. We're going to go ahead and come down here. We're going to say public void fade, well, how about this? Show map. Trying to think about how I want to handle this. So I probably should have a second mini map. Yeah. I'm actually going to break this into two things. So I'm going to say fade in delay and then fade out delay. And this is going to be delay before hiding the minimap after dragging ends. Okay. And then we're going to go ahead and say, so for show map, let's go ahead and say float delay is equal to 0. Oh, we'll just do that. And we're just going to say float t is equal to 0f while t is less than delay t plus equals time dot delta time yield return null. Pretty straightforward, I think. All right, so for show map, we're just going to go ahead and say start coroutine. Well, we'll say stop all coroutines, and we'll say start coroutine. Fade minimap. It's going to be fading in true, and then an initial delay. So it's going to be fade in delay. Actually, we're also going to make this a little weird. So we're going to say, I'm just going to add a little private bool is visible. Get return group dot alpha is greater than 0f. So if it's greater than 0f at all, that means it's visible. And what I want to do here is when we start this coroutine, if it's already visible, I don't actually want to have a delay. I want it to just instantly start going again. So we're going to say is visible question mark 0f. Otherwise, we're going to go straight into fade delay. So if you're already visible, basically if it was like fading out and then you start dragging again, instead of it fading out and then fading back in, it should just like stop the fade out and immediately start fading back in, basically. Okay, so with that, we're going to go ahead and say show map. So we want a public void hide map. We're going to go ahead and call stop all coroutines, do the same thing. And we're going to say fade out delay. This one we don't actually need the is visible check. We only need that on the show map. Hide map, because it's assumed you're always going to be visible there. So let's go ahead and say fade out delay. And this is going to be false. But here is the other thing. So I'm going to need a list, and this is what I needed the second script. Well, it might be okay. We can try it like that first. So I'm going to say private list image. I will do rect transform. Rect transform. Nodes is equal to new list rect transform. I think that's all we're going to need for now. I'm going to come over to here. I'm going to say private void initialize minimap. We'll just call it initialize. Okay. And we'll go ahead and say private void clean up. We're going to say for int I equals 0. I is less than, of course. Okay. Less than nodes dot count I plus plus. I basically want to have a custom script so I can do this more efficiently. I don't want to. If I do rect transform, that gives me an easier time positioning them, but I still have to use .gameObject to recycle them. So I need a second script that I can kind of handle this for. For now, it's fine to do it this way, I think. So we're going to go ahead and say on cleanup, we're just going to go through all of our nodes and then say pool manager.recycle. Recycle nodes of I.gameObject. That's all fine. And then we're just going to say nodes.clear. On initialize, we'll call cleanup. And then we'll say map dot, not map reference, should just be map, logic map, that's what it is. Logic map Oh boy. Let's go ahead and go to definition here. Nope. Trying to think through how I want to do this. I want it to be actually accurate, which means that I do need a script for this. So that's fine. That said, I do need to actually give me data for this, basically. So, do I have this publicly available? I don't. Okay. So I'm going to do a public list to reference this nodes, or these nodes, I guess. So we're just going to say public, not void, list cg underscore logic node nodes do. Just going to say get return nodes. Okay. So we're going to let that compile, and then I need to start a new script. Starting to get a bit late over here, so I have to go or head to bed soon. Tomorrow might be a busy day. Well, it is Monday. Mondays are always busy for some reason. But thanks for stopping by. I hope that you can get that code template stuff solved. It seems like something that should be possible. It might just be a bit esoteric to get things working properly, or the approach might be a bit esoteric. But... all right, so that is there. We're gonna go ahead and create a new script here. Create C# script. We're gonna call this cg underscore logic mini map icon. Pretty straightforward. I am not worried about showing connections at all. All I really need is probably some coloring, I'm assuming. So we'll want to know if the node is like a special color. So I'm going to say this is a rect mono behavior. This is going to be in textquest.custom-adventures. It's going to be using sleepyowl.common. Now we're going to be using unityengine.ui. And this is going to require, so we're going to need a serialized field tooltip, blah, 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 private image. We'll call this just image, I guess, is equal to null. Then serialized field. That's actually all we need. So we'll come back down to here. We're going to go ahead and just say public rect transform target get private set. I'm going to say public void initialize. And it's going to take a rect transform target and then a color. Okay, so all we're going to do here is we're going to say target is equal to target, and then image.color is equal to color. Let's see. Yeah, it might be a bit messy. If I get something unusable, I'll let you know. Cool. Looking forward to it. All right. Good night to you as well. All right, so for initialize, pretty straightforward here. I'm going to go ahead and say I have public void cleanup. We're just going to say image.color is equal to color.white, and then target is equal to null. And then we're going to say private void late update, and for this we're going to say if target does not equal null, then we're going to say basically all we need to do is rect transform, oops, wrong thing, rect transform dot anchored position is equal to target dot anchored position. That should pretty much be all we need to do. I'm not too worried about that, but I guess we can do that for fun. So we're going to go ahead and say target is equal to target, and in addition to that, we're going to say rect transform dot pivot is equal to target dot pivot. And then at the bottom here, we're going to say rect transform. I can't spell though. Rect transform dot pivot is equal to new vector 2 0.5f 0.5f. Okay, right in the center. Pretty straightforward. That's all we really needed to do there. We're going to pop back over here to logic minimap, and here we're going to just say initialize, and then we're going to say, since it's a rect transform, this is going to be CG logic minimap icon. We're going to do that. Then we're going to say nodes of I dot clean up. Pretty straightforward. And then on initialize, we need to go to logic map, and I basically just need to say okay. We're going to need to say logic map dot nodes, and that was nothing by itself, so we're going to say for int I equals 0, I is less than that dot count I plus plus, and then we're just going to say pool manager dot request, and then that's going to fall apart real quick because we've got to have this in here. So this is going to be, there's our group, there's our window rect, then we're going to have serialized field, tooltip, blah, 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 private rect transform, node, or how about icon area is equal to null. At the bottom here, we're going to say serialized field, tooltip, blah, 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 private CG logic minimap icon prefab is equal to null. Okay, so we're going to say icon prefab, spawning it underneath the icon area, and that is going to return the actual prefab. So we're going to say CG logic minimap icon is equal to that. And then we're going to go ahead and say icon.initialize based on logic map.nodes of I.rect transform. And then we're just going to do color.white for fun here. Pretty straightforward. That's all we care about. I think we're good. And then we're going to say nodes.add icon. Okay, I'm just going to rename this to icons. And that's all we need. So before we call show map, I'm going to have, actually, I'm just going to do this, public void reinitialize. I'm just going to call it initialize. I guess I could actually just make this public. Okay. We'll go ahead and grab this. I guess that means that I'm going to just call initialize whenever a node is added. Well, no. So when we call show map, we'll say if icons.count is equal to 0, we'll call initialize. Pretty straightforward there. And the other thing here is if we're going to say if not is visible, return. We're not going to do anything if you're not visible. And once it hides all the way, so we're going to say fade minimap. If we are, so at the bottom here, we're going to say if not is visible, we'll call, not parabox, we'll call clean up. Okay, just put that in one line, might as well. And then I think that will take care of all of that for us. So, all right, let's go ahead and let that compile, and then we can assign all that fun stuff. And while that's happening, I'm going to take a drink. Okay. So let's go ahead. Start setting this up. So list valid, list parent. Yes, node inspector. Okay. So I guess what we'll want to do here is, oh, I totally forgot to do that, but we'll set that up in a second. So we're going to want to say that we have a game object here. I'm going to put above the grid background, but below everything else, I guess. We'll put it above node inspector. I don't think it's ever really going to overlap there, but still. So all this is going to be our mini map. We're going to go ahead and put that right there. We are going to have this. This is going to be very interesting. I'm going to have this stretch all the way. The node inspector is 350, so we'll do 400 from the right, 400 from the left, 100, and 100. That seems roughly a good size. We don't want it to be too ridiculous. Also, I probably should do that in a second. We'll just get those taken care of before I forget. So we're going to go ahead and say fade duration. Say serialized field tooltip. Say private float full alpha is equal to, I'm going to say 0.5f. It's going to be max, I'll just call that max alpha actually. Max alpha. So it's going to be max alpha for the mini map when it is fully visible. Okay, we're also going to make that a range from 0f to 1f. Okay, and in addition to that, so we're going to come down to here, and so basically we're going to have to change this, so it's going to be mathf dot lerp from 0f to max alpha based on this. So we're going to go ahead and copy that. Okay, and it's going to essentially be the same thing here, and the same thing there, and the same thing there. Okay, and the other thing I needed to do is on initialize, we want to say right. Give me a second here. The window rect and the icon area. Okay. So, ooh boy, it's gonna get really awkward. I'm gonna make this its own thing actually. So I'm gonna say private void refresh map window. So we're gonna call refresh map window. Okay. And what that's going to do is a series of complicated things. So we are going to say, how awkward. We're going to say vector to map real size is equal to map reference dot get size. Vector to window real size is equal to window reference dot get rect size. And then we're going to say vector to map size is equal to map rect. Hold on. Map fading icon area window rect. I guess I can do icon area. That would kind of make sense. Yeah, that would make sense. No, it wouldn't. It almost would make sense, but so we're going to go ahead and put that here then. Say serialized field, tooltip, blah, 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 private, rect transform, map rect is equal to null, and this is the rect transform representing the total map. Okay, we're going to come back down here. We're going to be map rect dot get size. Oops. Size. Can't get it. There we go. Then vector 2. Sorry, I'm trying to think about how I want to handle this actually. Okay. So I think I actually know what I want here. So this isn't the maprect.getSize. I actually don't want that. I want this to be map parent size is equal to maprect.parent as rect transform. It's going to be. Okay, so with all of these, we can now affect our target things. So first things first, we need to basically say, so maprect dot size delta is going to be equal to, basically we're going to need to get the aspect ratio here. Go ahead and say vector 2 new map size is equal to thinking about how I want to do this. So we need to, I'm going to basically get the aspect ratio of the map real size, and then I'm going to apply that to our map parent size, because that's how we're going to determine the map size. So, oof, okay. Okay. I'm thinking this through. So, let's go ahead and say float map real aspect is equal to map real size dot x divided by map real size dot y. And for that, we are basically going to say our new map size is going to be equal to map parent size times map real aspect, I think. So if it's, let's say that our map size, our real map size is 5,000 by 5,000. Also, hello, the real Kleinba. Welcome back. We're currently working on a mini map to show over the actual map for custom logic. And we're going to use that whenever you start dragging the map around so you can see where in the map you are. We're currently getting the math handled on how to properly size that up. So if we have a 5,000 by 5,000 map, then the aspect ratio is going to be 1 to 1. So that means that our map parent size would be 1 to 1 as well. However, that's not actually correct. We want it to be square. It has to match up with the aspect ratio. Okay. So let me think. How do I want to do that? I guess that means we're going to do this basically. It's going to be equal to a new vector 2. These are a bunch of fun rect calculations that I probably should have in an extension class. Oh, by the way, I'm sorry for being rude, but I forgot to ask. How are you doing today? So for our new map size, we basically need to factor in what the aspect ratio of the original map size is, and then apply that to our map parent size. And that will give us what we want. So I think what we're going to do there is we're going to look for the maximum. So we're going to say oof, oof, oof. Let me think. Yeah. I guess we would want to do. That's fine. So let's go. Nope, 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 nope. Can't do it that simply. Of course we can't. So we're going to come back down to here. And this map real aspect, it's not going to be as simple as this. We actually want to divide the minimum by the maximum. So we're going to say mathf.min, and then this. Go ahead and grab this. Divided by mathf.max. If they're the same, again, that will come out to 1, 1. So that's our real aspect. And then we basically need to do the same thing here. So we're going to say our vector size is equal to new vector 2, where x is going to be equal to mathf.max. Is that right? Yes. So it's going to be equal to mathf.max between map parent size.x and map parent size.y. And then we are going to say times map real aspect blah. Okay, go ahead and copy that. We're going to paste this down here. So it's going to be y is equal to the same thing. Do I actually want that? So this will always give me a square, but that's not necessarily what I want. Thinking. No, that's not right. It's close though. So we're gonna do normalized values for this. I think that'll give me an easier time. So I'm gonna say vector2 map normalized sizes is equal to new vector2, and this is basically going to be how do I want to handle this? I've got to preserve the original aspect ratios while scaling them to apply here. So that means for the x, it needs to determine what the original size's x is, and then determine if it is larger or smaller. Sorry, I'm probably overcomplicating this. I always do this whenever I start trying to do normalized stuff. Are you just mad because I'm not using you right now? Yeah. So, what do we need to do here? What's the actual thing I want to say? We're trying to preserve the original size of the map, or rather the aspect ratio of the map. And then we need to apply that to our minimums. Okay. So let me think. We want to basically say, well, which one was larger? I guess that's the deciding factor here. So let's go for all right. So that's pretty straightforward, actually. We're just going to go ahead and do this. Is equal to this. followed by this. So y and then x. And then I think this is going to be the same, so we're going to say this is going to be equal to map parent size dot x times map normalized sizes dot x parent size dot y times map normalized sizes dot y. Okay, I think that gives me the size for the map that we want. Blah. So that means that our map rect dot size delta is now going to be equal to new map size. And then we basically have to do the same thing for our map parent, or our window real size. Okay, so we don't need you anymore, I don't think. I'm going to go ahead and comment you out. So map parent size. This should be the same for both, ideally. Is that correct? I'm trying to think this through. Yes. Actually, it'll be, okay. Yeah. Okay. So after this, we're going to go down to vector 2, new window size is equal to new vector 2. This is going to be based off of slightly different values. So what we're going to do here is we're going to say new window size, we're going to say x is equal to new map size dot x times map real size dot x divided, oh, sorry, hold on. And window real size divided dot x divided by that. Okay. So after that, we're going to go ahead and come down here. This is going to be y. Let's go ahead and do this. This is going to be map size dot y times windows real size dot y, map real size dot y. That is correct. The assumption there is that our map is always going to be larger than our window is, and that should always be the case, because otherwise what's the point of having a draggable map? So with that, we can then come down here and say window rect dot size delta is equal to new window size. Utterly ridiculous. Okay, I think we're good. I think that's all we really needed to do for that. So let's see what that looks like. We'll let that compile. And then we can start assigning other things. So for this, we're going to go ahead and let's just put the group on here. So we'll put the Canvas group here. It is not going to be interactable. It's not going to block raycasts. We can just go ahead and, can't do anything there. It's wait, hold on. Seriously? Okay, it's compiling. I was going to say, like, I thought it was compiling, and then it stopped doing the circle. Or then it started doing the circle again. I'm like, what's going on? Why can't I drag? Okay. All right. So let's go ahead and drag our canvas group in here. Then we're going to need a couple of things. First up, we're going to want to have, so we're going to have a rect transform. This is going to be, so this mini map is going to be the parent rect that I was talking about. We're going to go ahead and have a UI image. This is going to be our map. So we're going to call this map. It is going to be just size. It's going to be a standard rect transform. It's not going to be anchored. We want that to be our map rect. For the time being, I'm going to hard code it to be like 400 by 400, so it's roughly correct. We might do like 300 by 300. Okay, I'm going to give this a solid sliced. I'm going to make this black with a transparency of like 150. Actually, you know what? We're gonna do 255. It's gonna be like full transparency. We're gonna come up here to our minimap. We're gonna have our alpha be 0.5. There we go. Because this canvas group alpha is what's gonna drive all this. So I don't wanna start doing alpha in subcomponents of this. Otherwise, it's gonna get a little wonky. All right. So that's our map. We're gonna go ahead and I'm just gonna create an image. We're gonna give it a logic map icon. That's going to have our image here. The sprite is going to be, I guess we can make it the solid sliced again. We'll make it like a width and height of 8. That might be a bit too much. Can we go smaller than that? Let's go 4x4. Okay. That seems about right. I am going to go ahead and grab this. We're going to make this the node area. Or icon area, actually. I'm going to put this down here. This is going to be our mini map icon. Custom adventure mini map icon. Pretty straightforward for this. Create folder mini map. Grab this. Oh, come on, work with me here. Put this back here. Okay, let's go ahead and delete this. That's our icon area. So we got a couple of things. Here's our icon area. There is our icon prefab. The window rect, you know what? I actually don't know if I have this or not. That should be fine. So we're gonna go ahead and create UI image. It's gonna use a solid sliced again. This time we are not going to fill the center. We're just going to leave it like this so that we can see the bounds that we're looking for. I'm not going to bother sizing it. It should auto-size to be roughly the aspect ratio of this. That's the goal. Then we're going to go ahead and say, we're going to call this the window. Let's go ahead and drag that into here. All right. So our window reference is, I think, here. So it's the logic panel. This is window reference. The map reference is here. The logic map is here. And I think that's everything that we needed. So let's go ahead and set this up. So we're going to have an alpha of 0 to start. We're going to give it all this fun stuff. Fade in delay, fade out delay, fade duration 0.5. That should be fine. Okay. And all we're going to do here is on our map background, we go up to logic panel. I'm going to open this up. So basically what we want to do is we want to assign event listeners to when we start and end dragging on the background. So we're going to go ahead and close this. On start, we're going to say private void on map, or on begin map drag. Private void on end map drag. Then we're going to need a reference to the minimap, I feel. So prefabs, node inspector, behavior list. Let's go ahead and add another header. Serialized field, tooltip, CG underscore minimap. Minimap is equal to null. We'll say minimap. Come down here. And we're going to say, do I actually have that? I assume I did, but not good to assume that. Nodes parent. All right, so be it. Serialized field, tooltip, drips. Then private draggable map draggable is equal to null. Okay, so we're going to come back down to here. So I'm going to say map draggable dot on begin drag dot add listener on begin map drag map draggable dot on end drag on end drag dot add listener on end map drag. Okay. And all we're going to do there is we're going to say minimap dot show map, and then minimap dot hide map. Okay, pretty straightforward. Actually, what we're going to want to do here is, so when we call hide map, if we are, if it is visible, we're going to go ahead and call start coroutine. Otherwise, there's no real point to do that. And we can just say else clean up. So if we call hide map and the map is not visible at all, we might as well just clean it up. Because why would we bother doing a coroutine where it fades out if it's already all the way faded out? No real reason to do that. So let's go ahead and pop back here. I think that's all we really needed to do. So let's let that compile. Doing fine. What about you? I don't think I answered that already. Sorry, I kind of got onto a long diatribe there talking about about randomly dragging things around. Like always, whenever I'm doing a stream, we'll see how the stream turns out. But I think we're doing pretty well actually so far. Um, and of course, everything will work perfectly on the first try, and then I won't have to bother looking embarrassed or anything like that. We're gonna go ahead and assign this. We're gonna drag our background into there, and then I think we're good here. So let's go ahead and try playing. Well, that wasn't a good sign. It just like booted me from playing. Okay. I was gonna say I thought I didn't remember seeing that after I asked you that, but that doesn't mean it wasn't doing anything. Okay, so that's not correct. The window size is wrong. Um, the map size is roughly correct, but the window size is wrong. But it is doing what I wanted with regards to that. However, actually, we do have to restructure this a little bit. So we're going to come back here to our minimap. I'm going to put this up at 0.5 again. So this window is going to be here, and the map is going to be below it. Originally, I was going to have the window move, or I was going to have the window obviously be part of the map, but it makes more sense to keep the map separate because this map area needs to basically kind of like drag around to match where this map is. So it's going to look like that kind of. Okay. So the other thing we want to do is in this mini map is we need an update function. So we're going to say private void late update if is visible. Then we're going to go ahead and say maprect dot anchored position is going to be equal to map reference dot anchored position. Should basically be the same. And I think that will drag us around the same way that we would expect. I think. No. It's not. It's going to be close, but there's no normalized function, is there? Of course not. Okay. Yeah. All right. Cool. Fun times. We're going to add an extension method to rect transform extensions to help us do this then. Let's see here. I'm going to go to get rect size, come down to here. All right. So I'm going to call a get normalized anchor position, basically. So I'm going to come down to here. I'm going to say public static vector to get normalized anchored position. This rect transform. Getting things wrong is part of the process of programming. That's very true. So what we're going to do here is we are basically going to say, oh boy, oh man, oh no, oh no, this is going to make things so complicated. All right, so first things first, we are going to call vector2 anchored position is equal to rect dot anchored position. And then the next thing we need to do is, actually, we're just going to go ahead and do this. So if rect dot parent does not equal null. Return anchored position. Okay. And actually, I'm going to do this. Rect transform. Parent is equal to rect.parent as rect transform. So we're going to say if parent does not equal null. Then if it's not equal to null, we're basically going to need to do a bunch of fun stuff. Okay. So, trying to think about how I'm going to do this. So the idea of a normalized position is that it's 0 to 1, left to right, and then 0 to 1, bottom to top is how I'm probably going to do that. So to do get normalized anchor position, I basically need to handle what the pivot and the size of the parent recs are. So let's try this. Where does it get normalized anchor position? So if we don't have, or if our parent is not equal to null, we're going to say vector to parent size is equal to parent.get rect size. And then in addition to that, we're going to say we have to do arbitrary pivoting supported. I should listen to you since I was doing some UI stuff yesterday. So anchored position is, as you can see, it is a local value relative to the parent rect transform of a rect transform. So to give you a sense of this, see how this window has a position x and y of 0? If we drag this over, this anchored position is 76x and 0y. If we actually look at the debug value, you can see our local position in scales. Anchored position is essentially the same as local position in normal transform values, but they are translated for UI space. So it's not necessarily 76 units to the right, it's 76 UI units to the right, which is a local space calculation. So usually when you're dealing with rect transforms, you're going to be using anchored position, not position and local position. You can use those things, but they can sometimes give you weird, unexpected values. So it's ideal if you try to stick to anchored positions in this stuff. Although this is going to complicate our minimap fading in and out. So what we want to do here is on parent size, we're going to go, oh, and actually before I forget, because I know I will, on node, on behavior selected, we're going to go ahead and say, after all this fun node stuff, we're going to say minimap.initialize. That way it'll force it to update everything. But we're going to come back to here. 76 pixels. It's not exactly pixels because UI units aren't measured in pixels. They're measured in weird scaled units because UI is, well, Unity's UI always takes place below a canvas, which has its own scale and also its own reference resolution. So it's kind of a weird soft value. But you can think of it as basically 76 pixels in the resolution of the canvas that you're in, basically. That doesn't necessarily translate to 76 true pixels, but it translates into whatever that canvas is evaluating as pixels. So it's a little weird, but that's essentially what it means. Okay, so from here, I now need to, now that I have my parent size, I basically need to figure out what its pivot is, which is easy to get. We can just do parent.pivot. But from there, I need to then normalize the pivot. And then I can determine roughly where my rect is in relation to its parent. So this is super awkward. Okay, so actually, no. Okay. Let me think. How do I want to grab this? I'm going to actually grab my sketchbook here because that's going to make me have a little bit of an easier time trying to sketch this out. Okay, so I wish I had one of those old school teacher sketch things that would let me actually like draw onto a projector to show everyone what I'm doing. But it'll be a little bit faster if I just kind of do this. So we have our parent rect here, and we have our area here. And in order to get our normalized anchored position, which is essentially going to be like that, we need to grab what that normalized position value is, and then offset that. Okay. All right, I think I know what we need to do. Okay, so first things first, we need to get what our actual anchored position is, which we have, and then we need to use normalized value on the scale for the parent. So this is going to be very awkward. Could just be a webcam for showing. Yeah, that would work too. I just don't have I don't have the setup for it, and unfortunately, I don't have a lot of desk space, so I wouldn't really be able to pull it off very well. I'd have to have like a little side table that I could show that on. But that would be actually a really cool thing to have on stream, so that I could try to show people what I'm doing. Occasionally, I try to sketch stuff out in Photoshop, but it's just way faster and easier for me to sketch that out on notebook paper, honestly. Okay, so we have our parent size, and we have our anchored position. But now I need to know what my parent's pivot is, because that's what gives us our anchored position. Because our anchored position is basically calculated as offset from the parent rect transform's pivot. So if the anchored rect transform's pivot is 0.5, that means that its size delta, well, I'm trying to think about how I want to handle that. So let's go ahead and do this. Vector to normal parent pivot normalized. Well, no, how about this? Parent pivot position is equal to new vector 2, and we're going to say mathf.lerp from 0f to parent size.x based on parent.pivot.x. Okay, so that's our x value, and then mathf.lerp from 0f to parent size.y based on parent.pivot.y. Okay, so that gives us what our pivot position is within the parent rect. So if it's at 0.5, it should basically be halfway through its size. And then from there, we can, let me think, how do I want to handle this? So the problem that I'm having here is that parent rect transform pivots can be anywhere, and because of that, I have to take all those pivots into account. Trying to think about how to do this in the simplest amount of steps. We have our parent pivot position, and then anchored position is going to be, that might be all I need actually. So this is giving me my normalized, no, that's not normalized, that's just the actual position of the pivot. I need to know okay, wait. That might be good. So this true position is going to be this, vector 2. How do I want to say this? True position, I don't like that, but it's going to work. Is going to be equal to parent pivot position plus anchored position. So that gives me my actual position within the rect. And then from there, I can just return the normalized values. So we're going to say anchored position dot x is equal to true position dot x divided by parent size dot x, I think. And then anchored position dot y is equal to true position dot y divided by parent size dot y. I think that gets me my normalized value. So from there, we basically need to do the reverse because we want to set the normalized value. So we're going to need to say public static void. I'm sorry, not void. Well, no, it would be void. Set normalized anchored position. This rect transform rect. Bleh. So let me think. How do we want to do this? We basically, I guess. Oh, and in addition to this, we're going to give it a vector2 position. Normalized position. Okay. That means that I don't like that. It still gives me somewhat of a weird value. Hold on. Before we get too far down this mine field, we have our logic minimap updating anchor position, and then our size delta, unfortunately for the new window size, was incorrect. I think refresh is called an initialize. If not is visible, return. Oh, that's never going to be called, is it? Okay. Okay. This is going to actually have a bool. Oops. Bool force initialize is equal to false, and we're going to say true here. So we're going to say if not is visible, or well, and not force initialize. Right? So if it's not visible and we don't want to force initialize, then we're going to return. Yes. Okay. So let's try that. And before I do anything with get normalized anchor position, we'll try to just let that go. Oh wait, no, that won't. That won't work. We know that it won't work because the anchored positions are going to be different. So I do need to do normalized anchor positioning there. Gross. Okay. So that means that this is essentially going to turn into rect transform. Oh, nope. Wow. Oh, wait, no. Nope, that's still incorrect. So actually, that's a good thing that we figured that out, because we're gonna have to say rect transform dot set normalized anchored position based on target dot get normalized anchored position. We're gonna go back to logic minimap, and we're gonna do basically the same thing here. So we're gonna say map rect dot set normalized anchored position based off of map reference dot get normalized anchored position. So the reason that we can't just set anchored position to be equal to anchored position is because the area that the full map is going to be working on has much larger anchored position values than the minimap will, which means that it won't properly size. Like the dots would be all over the place. They'd be way outside the bounds of the map. So in order to get that right, we have to normalize it. Man, I'm doing like all of this in a way that I could have easily avoided if I had just used anchored positioning. Or not anchored positioning, but anchors. Oh well. So what we need to do here is for set normalized anchor position, we basically have to calculate the size of the parent again. I guess we could have this return the new position. Vector2. So we're going to need to do all of this fun stuff. Except we don't actually care about this, so we're going to return normalized position. Actually, no, we'll return rect dot anchored position at the very end. So we don't need this anymore. And instead, we want to say set normalized anchored position is going to be equal to that. We need our parent size, parent pivot position, and then the true position is going to be parent pivot position plus new vector2 mathf.lerp from 0f to parent size dot x based on normalized position dot x, followed by mathf.lerp from 0f to parent size dot y based on normalized position dot y. Okay, so that's our true position, and then I think all we're going to need to do is just say rect dot anchored position is equal to true position. I think that's all we needed. Is that correct? No, that's not correct. Hold on. Nope. 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 So this works for getting my normalized position. It does not work for getting me my or for setting my normalized position, unfortunately. Well, actually, I think we can just do that. I don't think we need this. Wait, hold on. No, we have to do this minus that, minus parent pivot position. Okay, so let's try that. I'm not 100% sure that that's going to do everything that we need, but I think it will. Okay, so let's go ahead and try this out. Oh, shoot. I also need to refactor how that's calculated. Minimap. This resize, we don't want to use the new map size. We want to use map parent size, don't we? Map parent size. Map parent size. Yeah, I think that's what we want. Because those are independent of one another now. Okay. All right, let's see here. Yes. So that almost worked. Clearly my get normalized position stuff is not actually helping with this. Okay. So that does seem to, let's see, map reference. Oh, that should be map rect. No wonder that wasn't doing anything. Okay. So let's see if that works. So it does seem like our bounds are being correctly calculated now, based on a normalized value. Now we just need to get the parent rect, or we need to get the map rect scrolling around like we would expect. I guess we should also test if the nodes will actually work. I will fix that afterwards. I also need to initialize it whenever I delete a node, not just when I add them. Okay, so that's almost correct. It's not quite correct, but we're on the right track. Yeah, our normalized values are kind of wonky here. I am going to add a bool here. Oh, yeah. Kind of, but not really. So we're kind of on the right track here. We don't quite have it doing what I want, but it does. You can see that it does have these nodes. Let's go ahead and do like get float. We'll throw those up here. And you can see that those nodes I think are correctly positioned. Oh, hold on. Okay, yeah. I do think that those nodes are correctly positioned in the sense that they are correctly positioned on the parent rect. So like they are roughly correct where they should be for the map gray box. Um, but clearly our map's position is kind of getting weird, so we'll have to work on that. But I do think that we can uh, call it a night there. We got pretty far with this. I actually do like having that. That's pretty nice. And I like how it fades in and out. And then it will go away if we fade out. Oof. Mwah. Love it. Probably should make its delay when fading out a little bit longer. Well, no. Actually, I think that's fine. But I do like having this. This is a very, very nice user feature or usability feature. So I think the only real thing that I have to do to get this to where I want is I just need to get it properly positioning our background rect here. It seems to be offset a little bit for some reason. But our window area is being calculated. It does roughly seem to be accurate in terms of its width and height aspects, but it's clearly not quite correct for positioning, at least for the actual background. But still, pretty good overall so far, I think. So we can probably try to get that working in a little bit. I am seriously though. I do think that I have those. I feel like those are roughly positioned where they are. So I think the nodes are positioned correctly, but I just don't think that the parent or the map rect is being quite anchored correctly. So, all right, I think that's a pretty good place to stop for the day. Hopefully that made up for yesterday's pretty terrible streaming. Um, so don't have any announcements off the top of my head. So we should be good to stream this week. And yeah. So, it's a pretty good place to stop for the night. So, as always, I want to thank you all very much for watching, and I will see you all next time.